Prescriptive process models, the Waterfall Model. The Waterfall Model is one of the earliest and most traditional software development methodologies. Introduced by Dr. Winston W. Royce in the 1970s, it represents a linear and sequential approach to software development, where each phase of the project must be completed before the next one begins. The Waterfall Model is also known as a prescriptive process model because it follows a predetermined sequence of steps or stages. While simple and easy to understand, the Waterfall Model is often best suited for projects with well-defined requirements and minimal changes throughout the development process. Overview of the Waterfall Model. Sequential phases. In the Waterfall Model, development flows in one direction, much like water cascading down a series of steps. This model divides the software development process into distinct phases, each with specific objectives and deliverables. Strict phase-by-phase progression. Each phase must be fully completed and reviewed before moving on to the next. Once a phase is completed, going back to modify or revisit it can be challenging and costly. Document-driven. The Waterfall Model places a strong emphasis on documentation. Each phase is documented in detail, which makes the model particularly suitable for projects with extensive requirements and regulatory needs. Phases of the Waterfall Model. The Waterfall Model consists of 5 main phases. A. Requirements gathering and analysis. This is the first and foundational phase of the Waterfall Model, where all project requirements are gathered and documented. The team conducts thorough analysis and discussions with stakeholders to create a requirements specification document, which outlines what the software should do. Goal: to ensure a clear understanding of the client's needs and to avoid misunderstandings or miscommunications later in the project. B. System design. In this phase, the system's architecture and design are created based on the requirements gathered in the previous phase. The design phase typically consists of 2 parts. High-level design. HLD specifies the system's overall architecture, major modules, and how different parts of the system interact. Low-level design. LLD delves into the specifics of each module, detailing classes, interfaces, and functions. Goal: to provide a clear blueprint that guides the development team in building the software. C. Implementation, coding. This phase focuses on actual coding, where developers translate the system design into functional code. Each module is built, tested, and integrated as per the design specifications. Goal: to convert the design into working software according to the previously established requirements. D. Testing. Once the software has been developed, it undergoes thorough testing to detect and resolve any defects or bugs. Types of testing conducted during this phase include unit testing, testing individual modules or components. Integration testing, ensuring modules interact correctly. System testing, testing the entire system as a whole to check for overall functionality. Goal: to validate that the software works as intended and meets all specified requirements before release. E. Deployment and maintenance. After passing testing, the software is deployed to a production environment where users can start using it. Maintenance activities, such as fixing issues, updating the software, and adding new features, are handled as needed. Goal: to ensure the software continues to function effectively over time and meets the user's evolving needs. Advantages of the Waterfall Model. Simplicity and clarity. The linear and sequential approach is easy to understand and manage, making it suitable for teams that prefer a structured development process. Documented phases. Extensive documentation at each stage ensures clarity, helps maintain focus, and serves as a valuable reference for future maintenance. Clear milestones. With defined phases and deliverables, the Waterfall Model makes it easy to track project progress and set clear milestones. Ideal for well-defined requirements. The model works well when requirements are clear, unchanging, and unlikely to evolve over the course of the project. Limitations of the Waterfall Model. Inflexibility. The rigid phase-by-phase approach makes it difficult to accommodate changes. Once a phase is complete, going back to make changes can be time-consuming and costly. Delayed testing. Testing is conducted only after the entire system has been built, which increases the risk of identifying major issues late in the process. Not ideal for complex or long-term projects. Projects with evolving requirements or a high degree of complexity may struggle with the Waterfall Model, as it doesn't allow for iterative adjustments. Potential for misinterpretation. If requirements are misunderstood early on, correcting them later is challenging, often resulting in costly rework. When to use the waterfall model. Projects with well-defined and stable requirements. The waterfall model is best suited for projects where requirements are clearly defined from the start and are unlikely to change. Shorter projects. For small to medium-sized projects with straightforward objectives, the waterfall model can be highly effective. Regulated or document-heavy projects. Projects that require thorough documentation, such as those in healthcare or government sectors, benefit from the extensive documentation at each stage. Real-world applications of the waterfall model. Construction and manufacturing. Since these fields require sequential completion of stages, e.g., foundation before structure, they align with the waterfall model's philosophy. Embedded systems. Projects with well-defined hardware specifications, like embedded systems, often use the waterfall model due to its clear and linear structure. Military and aerospace projects. These industries require high levels of documentation and planning, making waterfall a suitable choice. The waterfall model remains a foundational process model in software engineering. While newer models like Agile and iterative approaches have largely replaced it for projects with dynamic requirements, it continues to provide a reliable framework for projects with stable, well-defined needs.